Hi, welcome to Magnetite Math. Today's video, I'm going to show you about the curious case of numbers 27 and 37. And what's so special about them? Well, first off, I'll show you the reciprocals of them. Reciprocal of 27, that is 1 divided by 27, is equal to 0.037 repeating, or 0.37 for example. Same with reciprocal of 37. That is equal to 0.027, 0.27027 on and on. So why is that? That is due because and 27 times 37 is equal to 999. And since that's the case, you multiply those together, either which way, you'll end up in an infinite sequence of 9s, which ends up being equal to 1. And there's another interesting property of both of these numbers. Say I multiply 27 by 5, I get 135. Now here's an interesting property with that number, and that is if I get rid of that 1, put it over here, still a multiple of 27. If I get rid of that, put the 3 over here, it's still a multiple. I can keep flipping these around, see I'm back to the original number. Will it work with a multiple of 37? It will. Here's 185, which is 5 times 37. If I get rid of that 1, put it here, same thing. Same multiple of 37, put the A over here, it's multiple of 37. And now work with any of those multiples of them above 100 and below 1,000. So basically, any 3 is a multiple of them. So why is that? Well, that basically, if I designate k to be equal to a multiple of 27 or 37, and I want to do this flipping around of the number and have it still have that property with it, what I'm actually doing is the same as multiplying that number by 10, then subtracting multiple of 999. Or I'll denote as n is a multiple. I'll denote 999 as 1,000 minus 1. So to help you understand what I mean is, let's say k is equal to 135. That is 27 times 5. So take 135, multiply it by 10, then you get 1,350. Then n is equal to 1 because that's what we're going to subtract. So in that case, I'll subtract 1,000, add 1, and then like 351. So, and same thing here. If I take this, multiply it by 10, get 3,000. Let's get a 0 here. 3,510. Then I'll subtract third subtract the third multiple of 1,000. So 3,000 and plus 1. Third multiple of this. And so subtract that 5 over 10. That's what I'm doing. And then 5 over 13. And so that's basically what's happening. natural question I would have is, we're just working any other number bases besides base 10. If you don't know already what base 10 is, that's just basically where we have 10 symbols for one-digit numbers and our common everyday numbers. So we have 0, the symbol 0 for 9. Whereas in a programmer's base 16 or hexadecimal, you have 0 for F or 0 through 15. So that's 16 symbols. As you may know, computers do binary, that's base 2, so you have only 0 and 1. And this is and after each of these, you get a new, it was a combination of symbols, which we normally interpret as 10. So let's see, what if I try doing this in base, could possibly be doable in base 12. Well, in base 10, this works because 111 is divisible by 3, is actually a product of two numbers. 37 times 3. So do we have something similar, say, for example, base 12? So let's see, 12 squared, 144, plus 12, 156, plus 1, 157. So 157 is prime. Just in case you're not familiar with bases, this is the 10 squared column, the 10s to the first power column, and the 10 to the 0th power column. So 100 tens, 1s. This here, base 12, would be 12 to the second power column, 12 to the first power column, and 12 to the 0th power column. So I'll designate this here as prime because it's only divisible by itself and 1. So this is not going to work in base 12. Let's say we try base 14. So 14 squared, 196, plus 14, 210, plus 1, 211. No, 211 is a prime number, I happen to know. So that's not going to work. How about the programmer's base 16, hexadecimal? Well, 16 squared, 256, plus 16, 272, plus 1, 273. And that is 91 times 3, and 91 is 7 times 13. So that will work, and probably also with some interesting properties too. So reason 2737 have that property is actually a property of the base 10 number system that we have. If we use a different base, like say base 12, that would not work as far as I can see. And if it did, it wouldn't be the same way. So anyhow, thank you for watching. Hope you found this interesting, and you have a great night. Take care. Bye.